very much.
And then once that work is
Thank you very much. So I guess the only way to start this presentation is to say that I'm going to introduce the idea of unit test documentation through the means of interpretive dance. If only that was possible. So I'm going to talk about unit tests, hopefully give a slightly different direction on how you can view your unit tests, and see how you can approach them as a way of providing documentation for your system. So I think the reason why I started thinking about this is because we've all debugged somebody else's unit tests. We all have that situation where we make a change, it's seemingly innocuous, and suddenly you get this wealth of failures, and then you have to dive into somebody else's unit tests, and they make no sense whatsoever. How are you supposed to pick this apart? And I think that, you know, it's an important topic, not just about how you write unit tests so that they're readable, but how you can write unit tests so you generate more value out of them. They are one of those things that mean that some people want to work away from admins and put them, work away from developers and move them into admins because we have a slower development cycle. But, you know, they are incredibly valuable things. Obviously, you can't start any of these talks without saying a little bit about who you are. My name is Rob Baillie. I work for Make Positive. I imagine one of the least certified people in the room. You know, there's a room of luminaries amongst the Salesforce world. I've been at Make Positive for just over a year and a half, working with Salesforce for about 3 years. So I still don't regard myself particularly as an expert in Salesforce as a developer. But the main thing is I've been writing unit tests now for about 14 years. I'm in that strange situation where I worked somewhere for a long time, and so I have debugged unit tests that I wrote 10 years previously. So I feel as though I have a slightly unique view on unit tests, especially in the Salesforce world, which is a heavily consultant-led world where we tend to do something and then move away quite a bit, as I'm learning. But yeah, with 2 decades of development experience, you like to think that you'll learn something about it. I would talk about Make Positive. We're hiring. Yay, come join us. We're amazing. Yep, great. So the big question is, why do we unit test? And the simple answer to that question is really because Salesforce. You know, Salesforce require us to write a certain amount of code coverage for our Apex that we produce. We have to have 75% code coverage. And Salesforce have a very good reason for that. They like to be able to ensure that when they upgrade your environment, they can run the Apex hammer and they can make sure that your system isn't going to break when they do that upgrade. And the only real metric that they can use to do that is the code coverage metric. And it's very useful for them. But why did Salesforce come up with this? Well, the answer to that is they didn't come up with it. This is not a Salesforce-specific thing. So it's not to do with the fact that we run in a multi-tenanted environment, and it's not to do with the fact that Salesforce want to be able to run these things for us. It's because it's a fairly well-recognized good practice within the industry, within the software industry. And with that in mind, we kind of have to ask ourselves, why does the software community as a whole value unit tests, and why do we write it? And for me, the answer to that is really threefold. And the 2 first points of that are the things that people really tend to focus on. That we want to prove that the functionality that we put into our system works. That what we say the system is going to do is what the system will do. And then once that's in place, to make sure that whenever we make any changes to the system, that it continues to do that, and that we don't reintroduce issues that we saw previously and fixed, or that we don't stop functionality from working. So we want to have a certain amount of certainty about the stability of the functionality that we've implemented in the system. But a third point of that, which is something that tends to be overlooked, I think, is that we want to use them to document our intention for our code base. We want to make sure that people are aware that the functionality we've implemented is not accidental, that we have made a conscious decision for our system to behave in a particular way. And the simplest way for us to do that, in my opinion, is for us to write a unit test that proves that that is the case and describes that to people. So, why document intent? It's easy to say that we want to do this, and we have clients to serve, and we have masters who pay the bills, so there has to be a reason for that, beyond the fact that we as developers think it's a good idea. And that really is, the sell to our clients, and I have previously worked in environments where unit testing was not a requirement, and it was something that we wanted to do. And so we did have to explain to people why it is that they should allow us to spend their cash doing this. And the big points for me are that it increases our confidence to change the system. So it means that as we introduce changes, we can be sure that those changes are intentional, that anything that we do that changes behavior that we have not described is alerted to us, that we can cover that change and we can say, this was what we intended to happen. Especially important, I think, in a consultancy-based environment is that collective memory. It's very hard to remember what we thought the system should do years ago. It's particularly hard for a team to remember when that team is no longer in the organization. And as a consultancy, Make Positive, and I'm sure a lot of you are consultants as well, as is the Salesforce way, we move into our clients and we build functionality and we walk away from that. Unit tests are a fantastic way for us to provide our clients with a great memory of all of the intentions of our system. And beyond that, I mean, we could, if we wanted to, and I'm sure a lot of people do, and we're included in this, produce a huge amount of documentation. We can use wikis and Confluence and so on to describe everything in minute detail. We have our stories in Jira or in whatever we might use to track them. We have well-named classes. We have beautiful variable names and beautiful method names that describe what these things do and what their intentions are. But the problem with all of those forms of documentation is as you change the functionality of the system, you may forget to change the documentation that goes with it. As you describe behavior through your unit tests and through the assertions that you make particularly, you are guaranteed that those assertions are accurate. As soon as you run a test and the behavior is changed and your test describes the behavior, you will be alerted. You are told that your documentation is wrong. And that is something that you can't say about any other form of documentation. Testing, particularly, so you could say that about integration testing and so on and so forth, but scripted testing is really what we're talking about there. So the question is, I think, how do you make good documentation out of your tests? And you need good documentation in order to get value out of it. There's no good in writing documentation that you cannot derive value from. And the three things, again, I come back to these three things, or I'm a big fan of three things. You only get value, really, if you document the right things, and that your documentation is reasonably complete. It can't be exhaustive, but if it's reasonably complete, you can get a lot of value out of it. And the third point being that it has to be easy for you to read so that you can understand it when you reach it. And for me, you can change the word docs or the word document to test and you get the same result. If you can write tests that test the right things, that are reasonably complete, and that are easy to read, you end up with a suite of tests that form documentation for your system. Now, I could spend a lot of time on testing the right things. That is a big topic in its own right, and 45 minutes would not do that justice at all. But I'll gloss over that a little bit, again, hopefully to give us a way of thinking about tests that is not the Salesforce way. And I will also look at, in more depth, about trying to make sure your tests are easy to read. Because I think that is the thing that we can generate real value out of. So we start off with testing the right things. And some more beer. So, the question to the audience is, which metric will tell you that your tests are complete? Are we going to get anybody who's going to say anything at this point? No, of course you're not. Because there isn't one. I think the Salesforce way of describing this is code coverage is king, basically. They love code coverage. The reason why they love code coverage is because you can measure it. That is the only reason. Code coverage doesn't really tell us very much at all. Yeah, but, you know, I did all the trailheads, and they've taught me how to write unit tests, and they said that I need to have code coverage, and you know what? You do have to have some, but I'm going to give an example out here, and when you see this, immediately forget it. This is the solution to the last part of the Apex Advanced Specialist Super Badge, which is the last prerequisite before you take the Platform Developer 2 exam, which, despite the fact they've tried to devalue it quite a bit, is still the marquee exam for developers in Salesforce before you set off on the CTA path, if that's what you want to do. And the requirement for that test is that you must have 100% code coverage for your class, and you must have an assertion. Which means that this test will pass. Now, I'm not saying that Salesforce should teach you how to write unit tests, that I'm not criticizing Salesforce for failing to do that. I'm saying that that's not their concern. Their concern is to teach you how to use the framework, not how to use it the right way. This test can be passed with this class. It doesn't even return anything. It does nothing. It returns anything. You know, that test, all it does is prove that you can execute each of these functions, or each of these methods, sorry, and none of them will throw an exception. Now, obviously, that's a pretty extreme example. But I think it serves as a reminder to what Salesforce's failings are in the trailhead sense. So, code coverage. Why is code coverage a bad thing? For me, code coverage means very little. I antagonistically say it means nothing. It doesn't mean nothing. If you've got 20% code coverage, you definitely haven't written enough tests. However, if you've got 100% code coverage, that doesn't mean that you've written enough. The main points behind that is that executed doesn't mean tested. We've seen the extreme example of that. But there are some tests that you will write in your lifetime that prove that code does not execute. The prime example of that, two prime examples really, are the if statement. The if statement exists in order to skip code if some condition exists. If you purely write tests guided towards the goal of 100% coverage, you can write tests that will fall into the body of your if statements and never test that the if statement is checking the right condition. That you have to check that your code behaves correctly when certain conditions are not met, that sometimes some things don't happen. Another great example of that is a SOCL statement. A SOCL statement is one statement, but that one statement can encompass a huge amount of functionality. Records that you should include, that you should not include, fields that you should retrieve back. So when you're writing a test that covers a SOCL statement, you should be creating data that is included and is not included and has invalid values in it so that you can prove that that data comes back correctly from that statement. But I think even more importantly than that is if you're using tests well when you're writing your code, you will write that code to prove that your code doesn't yet cover a situation. When you start thinking about the code that you've written, you can start thinking about, well, actually, what happens if I I can write a test case that says, well, actually, I haven't really checked to see what happens if I take the square root of a negative number. What happens when I do that? Do I get an exception? Do I get a null value? Do I get a 0? You don't know until you try it. And you can try that using your tests. And when you get the result, you can describe it as intentional. To kind of further push that point about code coverage, I mean, I didn't go to Dreamforce. I was not lucky enough to be a part of that side of things. But there was a developer theatre that had a talk on it. Now, I would like to think that this was a particularly antagonistic title that was to draw people in. But Salesforce are really so wedded to this number of code coverage that they will even put on a talk that says, get your code coverage to 100%. I don't care if you reach 100%. The aim is not to get to 100%. It's to get to 100% of the things that matter. You need to be testing the things that you care about, that are complex, that require a good degree of testing, and you need to test the variations for those. So if we're not going to think about code coverage, how else can we think about our test coverage? For me, functionality coverage is the key, really. What we want to be starting to think about is how is our code going to be used, and when it's used, how do we expect it to behave? And we want to describe that in terms of how things behave from the outside as much as possible. Things that are big red flags for me are testing private methods using test visible, for example. We don't want to test what a piece of code does, but rather what we expect it to do when we put it in certain situations. And when we start to think about tests in that way, I find that the test cases that I produce are much easier to understand, especially from people who are not necessarily that tech savvy. In terms of, if we describe things in terms of we set a member variable in a particular way, that doesn't really tell us anything about what it does in any real sense. But if we say that when I call this method, these behaviors are exhibited, that makes more sense to us as human beings. It helps us to understand what this piece of code is useful for, rather than just precisely what it does. As you do that, and as you start to think about code in that slightly different way, and especially if you think about, you try to divorce your testing from your implementation, you start to think about ways in which you can use your code in ways it wasn't intended, and how you can find your edge cases where things don't quite behave in the way you might expect it to. And as you divorce yourself in terms of from the implementation, the particular implementation of your piece of code, it allows you to then restructure that code underneath the hood and change the way it's implemented without changing its behavior. As you do that, you hopefully can start to reduce the amount of code that you write. And I think one of the things that really stuck with me from something that somebody said that I respected a long time ago is every line of code is a potential bug. The less code we write, the fewer bugs we inevitably have. So that's great. Hopefully we're starting to think about our tests in a way that means that we're thinking about the coverage of that code in terms of its functionality coverage, and we want to make sure that we express as much functionality in the system as possible. But that doesn't really help us to write it as documentation. It simply helps us to write tests that will catch more bugs. It doesn't really help us when those bugs appear and our tests start to fail. So the meat of this, hopefully, is about how we then start to approach our test writing in a way that means that we can find useful documentation in it. And I want to present to you an example test, which I think is a fairly usual kind of unit test that you would find. It's probably a bit shorter than what we find. I don't know what your experience is with unit tests in terms of other people's, but this is, I think, fairly typical of a Salesforce test. You have a test setup, that's quite useful. We create a factory. We have factory methods, they're good. We can create data in our factories that mean that we don't have to see all of our inserts, we don't have to see all the data setup. So that's great. We've done some abstraction, that's great. So some good things to see. We are testing something to do with legitimate expiry, okay? So we're in the world of GDPR, so I presume everybody's familiar with the idea of legitimate expiry. We want to make sure that we keep data only for as long as people are interested in our organization. Okay, so we set up a date. We don't know what we use it for, but we set up a date. It must be important. We set up a factory, and we create a candidate, and then we get it back. Okay, so we're interested in contacts. We create a task, and then we get a contact back again, and then we make an assertion. So it's definitely something to do with legitimate interest expiry, and something about creating this task means that the expiry date isn't set. Okay. Then we create another task, and then we look at that, and we say, right, we get another contact back, and we see that the legitimate interest expiry is set. Okay, so we can infer from this that something about this creation of this second task has set the expiry date. We don't really know what it is about that second task. There's some stuff that's different. There's a gold note passed in here and a left note. That might be useful. It might be the fact that it's the second task that's being created. We don't really know. Now, this test will fail if this behavior changes. But if you're the developer that comes into this test and that second assertion has failed, you don't really know why it's failed. You don't really know what it should have done. You just know that something's gone wrong. And that leads you down into a world of second guessing. So, I do like to show my arse off to strangers regularly. So the first step towards making our tests a little bit more readable. I would say the first thing is to make your tests expressive. And when I say expressive, I mean that we want to try to make sure that we do things in a logical order. And this is the same as we would do with any other piece of code. You know, you generally would not, I hope, create a variable a long way away from where you use it. You wouldn't name a contact C. You know, surely you would give it some kind of name, give it some kind of context for what it is. You want to make sure that you're not hiding things that tell you things. We've abstracted some things in that test. We created some data factories, and that's abstracted some things away. Hopefully, we've not abstracted anything away that tells us something useful about this test, about what it's doing. We didn't use start test and stop test. I think there's a good reason why a lot of people don't use start test and stop test, because you need to use them later on when you blow your SOCL limits and you want to reset them halfway through, but we'll get onto that later. But you alluded to that a little bit. We use variable names and we use method names carefully so that it describes what we're doing. It describes our context a little bit more. And one thing that was blatantly missing was we didn't use any assertion text in our text. We didn't describe the context for our results that we were looking for. So what happens if we try to change this test a little bit so we make it a little bit more expressive? We've not done a huge amount here. The first thing that we've done is that we've said that this test is nothing to do with the creation of our contact. Simply by putting our start test in here, we've said this is immaterial. This is not what we're testing. This is just some setup that we perform prior to us starting our test. Then what we do is we create a task. We give it a name. When we retrieve our contact back, we say this is our original contact, so that when we're referencing this later on in the test, we know that we're not referencing the thing that we've updated. We're saying, this is the original shape of this contact, so we can go back to that. Okay, maybe we didn't need to do a SOCL in order to do that, because all we're doing is using the ID for it, but hey, let's go with that. We then create a task, and we say something about that task in terms of its variable name. We say this is a task that will not extend our legitimate interest. And we give it a subject, some text that expresses that a little bit more clearly. In case you didn't miss it the first time, you can see it a second time. I'm a big fan of don't repeat yourself, but in tests, sometimes it does help to hammer the point home a little bit. We pass in a date and we pass in some other stuff, so there's still a little bit of confusion around what this might be. But then when we get to our assertion, we use text to describe what it is. And at the moment, we're being a little bit more useful, but we're not being brilliantly useful is to start to say now that adding this task does not extend the legitimate interest, and it will not update the legitimate interest expiry on the contact. Okay, we're not really saying much more here than we're saying in this piece of code. It's just that little bit more expressive. Now, don't get me wrong. I'm not saying that this is a great test. I'm just saying it's better than this one. So the next question then is, well, how do we make it even better? So our first tenet was to say that we want to be a little bit more expressive. The next thing is that we want to try to be concise, and by that I mean we want to be brief and we want to be comprehensive. A big part of that is by saying we want to test a single scenario at each time. And this is something that the Salesforce documentation misses completely. In your unit test, you want to make sure that you isolate your test cases and you do one thing at a time, and you describe the outcome one at a time, even if it means that you do the same thing multiple times in different tests. That's absolutely fine. In your test scenario, you want to make sure that you only do what is required to test that scenario and you don't do anything else. If you do need to do more in order to set things up or make sure that data's in the right kind of shape or anything like that, you hide it as much as possible so that people are aware that it is not important. Or even better than that, they're not even aware that it's happening. Data factories are definitely a step in the right direction for that, and they help us. But let's have a look at what our test might become if we start to use that. So the first thing I think we can see is we have split this up into two separate cases. What this does, just that simple case of splitting those two things up, is we are saying the creation of that first task has absolutely nothing to do with the fact that the second task extends the expiry date. It doesn't feel like an awful lot, but as you're somebody who's coming to this test and all you've got is a failure, the fact that you've split that up tells people these things are unrelated. By splitting that up as well, we can then start to really narrow down our start test and stop test so that we can say exactly what it is that we're testing, precisely what it is that we're testing. And what we're testing here, I shouldn't use the word precisely, is that the creation of the task does something. I would say in pretty much all of your tests, as much as possible, abstract out your SOCL. Okay, we understand SOCL, we can read SOCL, but it's noise, it's lengthy. It takes you time to read, so actually if it's doing something simple, like it's just getting a lot of contacts, you don't care what the fields are at this point. Maybe you don't care how you decide which ones to get. The only thing you care about is that they are the right contacts. So we abstract that away, we put it into a method, hide it away. Similarly with the create task, data factory methods are very useful in tests, but seeing data factory 27 times in a test is not useful. Abstract that away, put it into a method. It's the creation of the task that's important, not the fact you're using a data factory to do it. Once that contact's then been updated, we get it back, we use the original contact ID to do it, and we can check the value of it. This test is significantly shorter now than it was. It's far less wordy. It's given us the opportunity to write sort of Java doc, PHP doc, whatever doc style comments. I've not really gone down this route yet, but I think there is a real scope for using these kinds of comments to generate documentation. We can combine Java doc style comments on our classes with outputs from our tests in order to give really rich documentation. I've never been a fan of Java doc style documentation, but if you add conditions into here that says this is the method that's going to run, and in this situation, it will do this, you then start to get something that's useful as somebody who's come into a class and never seen it before. It's something that's woefully missing from the Salesforce docs. I mean, finding out what methods do when you pass a null into them is almost impossible without trying. So the next thing then, I think, is to try to be precise when we're talking about our tests. So One thing that we did not, you may have noticed with our previous tests is that we were just saying that the interest expiry is set. We're not saying what it's set to. I think we should be testing things like that. We should be as precise as possible. Everything is in our control, within reason. We're setting up the data. We're calling our methods. Most of our methods are entirely deterministic. So we can say exactly what should happen. Now, with the Salesforce hat on, some things that we do are driven by configuration, and we want to make sure that our tests don't fail just because somebody changed some config. So in some situations, you may need to pull some config out in your test and make sure that you are changing the behavior of your test based on the configuration. That's absolutely fine. What you're doing when you do that is you're expressing that the configuration is important. We do need to make sure that we're not just replicating code that was in our class with code that's in our test, but still, we can certainly be a lot more precise than we can get away with just by thinking a little bit. So I would always err on the side of using assert equals rather than using assert, and I would definitely make sure that I put my expected and my actual the right way around, because when you get that message back saying, I expected this and I got this, and you go, but it can't possibly be giving me back this. Why is it giving me back this? So get them the right way around if you are going to do that. So what happens to our example test if we start to be a little bit more precise about what happens? Well, at this point, I would say constants are the test's best friend. We had a lot of literal strings in our previous test, and those literal strings didn't really tell us anything about what they were. We could have had a look at our data factory and found out that the fourth parameter that we passed in that was a string was the task type. Yes, we could have done that, but why do we make people do that? Instead, what we can do is we can create a constant that tells us that this is a task type that extends the legitimate interest, so that when we create this task, we can see, if I create a task against this contact, and it is of this type, it's a type that changes the legitimate interest extension date, it will change the date, and it will change it to a particular date. Now that 18 might be in some configuration, we might retrieve that out, as I was saying before, but the fact it's driven by configuration doesn't mean that we can't test that precisely. This is a particular habit that I got into using other environments. I honestly don't know whether or not tests run in a particular time point or not, but if you are testing with dates and times, I would suggest you always use a constant to do it if you can. If you're doing things based on created date, well, we'll be tied you. But dates do move, time ticks on. You can run a test overnight and it can be a different day even. So if you can use a constant for your dates, then do it. And as I said before, describe that time, describe that date. It turns out I shouldn't have created one called next week, but hey, sue me. Okay, so I think it's pretty safe to say that when you look at a test like this, okay, you still need to think. Okay, of course you need to think. But hopefully, you can see how by using expressive, by being expressive, by being concise, and by being precise, you can make a test that is far easier to read than that and is far more useful to you when something goes wrong. I challenge anybody to argue with me on that point after I've finished. Okay, so I mean, it would be remiss of me to not talk about some of the other things that are particular to Salesforce. Yes, we are setting up data. Yes, data is complex. Yes, we can create more data in our test than anybody's ever going to create in a single transaction. And we no longer have start test and stop test available to us because we're not bastardizing their use in order to get us around DML limits. So data setup. Only insert data if you need to insert data is a prime point on that. If you can write your code in such a way that you've extracted the code that accesses data from the code that processes data, you can test your processing without ever creating data. There are limitations to that. Relationships between objects can cause problems. Formula fields always used to be a problem. They're not so much anymore. We can recalculate formula fields in memory now, as long as they're not traversing relationships. We don't even need to insert data in order to test that formula fields are set in particular ways if we want to. We should only be creating the data that we need for our test. We're being very, very concise and very precise, so that should be absolutely fine. And we can use data factories for doing that as well. Data factories can be used to even default things. If you're creating something that's related to a contact and you don't care what the contact is, you can use data factories to default that contact to a standard one, which means you're never creating more contacts than you need. You never see that in your test, even in your abstractions. I could do a whole thing on data factories if we wanted to. I would consider switching off triggers and workflows and process builders and things like that. Obviously, we all have frameworks that we use in order to make that easy to do it. Generally, I would say that's probably not such a great idea because you're then isolating yourself a little bit too much. So if you can get away with never switching those things off in your tests, I would suggest that you don't. Another part of this is one of the things that can confuse people when they're running tests and they've failed is that the thing that fails is not the assertion that's proving that a piece of functionality works, but rather it's that assertion, that really handy assertion that you put in to prove that, all right, I did create 6 contacts. Look, I've taken the count out and I've proven that there's 6 of them. That contact is at the right status before I do anything with it. I'm not entirely convinced by them, but if you are going to use them, make them very clear. Point out, this is a data setup assertion, so that when that happens, people can see it's not my test that's fallen over, it's the setup of the data before the test runs that's caused the problem. And I think this is, from my experience, I come from a slightly test-driven development world, which is hard in Salesforce, but it's not impossible. But what I will tend to do is I'll write my tracer bullet functionality, so the basic functionality of my class or my method, so that it basically works. Then I'll write a test that proves that it works in that basic scenario. And at that point, I will stop and I will plan what I'm going to test. And I will do that separately from writing those tests. Because when we get into the habit of writing our tests, when you start getting into that nitty-gritty of setting up the data and making the assertions and making things pass the tests, we get caught up in the detail of writing the test rather than deciding what the test should do. So I would always split up that planning of what it is you're going to test from implementing those tests. And when you get to that point where you think, you know what, I should have tested that as well, I would stop, I'd move away from the apex, and I would start writing comments or notes in a notepad or whatever, however it is that you do that. But actually, what's this test case? What should I expect to happen in this situation? And if we're thinking about our tests in terms of functionality rather than in terms of implementation, those statements, those single sentences are really not that hard to write. Turning them into code is difficult sometimes, but actually deciding what the test should test for is generally not that difficult. I would also build up my tests from the simple to the more complex. So you test your tracer bullet, you make sure that you add things on. You can use numbers and naming convention in order to make sure they run in a particular order if you want to. Salesforce will run your tests in alphabetical order, so you can take advantage of that and make sure that your simple cases run before your more complex cases. So the first thing you see is the simplest scenario that's failed. And I would consider, if you've not tried test-driven development, I would urge you to try it. Write the signature for your class. Write tests before you've written any piece of code, and then start to bounce around between writing code and writing tests. And then I think, and this is something that you see time and time again, people don't do. We do this all the time with our code. We do this all the time with our flows. When we've written something, we will look at it. We will reread it. We will see if it makes sense. We can see if it can be simplified. We can see if it can be made more generic. We should be doing that with our tests. We should be looking at them and saying, can I make these easier to understand, more robust, simpler? We should be deleting lines from our tests to make sure actually in this scenario, this is a thing that I changed to make the scenario different. If I comment that out, this test should now fail, surely. You know, if I change this type for this type, then that assertion should no longer be true. Try it. If you haven't seen your test fail, in my opinion, you've never seen it pass. Because unless you know it can fail, that pass doesn't mean anything to you. The other line of it is to start deleting lines from your code. This is kind of the opposite of code coverage. It's the absence of code coverage. What happens if you delete that where clause from your SOCL statement? What happens if you delete that if statement? Does something point out that somebody has deleted something? Because rest assured, somebody will. Somebody will look at that class and say, that doesn't make sense, delete it. And when they do that, you want to make sure something fails. And I want to reiterate that point that I made earlier. It's very easy to write a test that cannot fail, or that is hard to make fail. And if it has never failed, it is not a test. If it cannot fail, it is not a test. All you're proving is that the signature is right and your class doesn't throw an exception, or your method doesn't throw an exception. There are other ways of thinking about it, which some people will adhere to, I'm sure, but we're not one of them. But we go back to that point earlier on, how do we know we're finished? From a code coverage perspective, if you were using that, then you would say, if I reach 90% code coverage, I've done my job. For me, what I at least ask myself is, if I deleted all the code in my system, would I be able to rebuild it just from the assertions that have failed? And if the answer to that is yes, I could, I have an amazing test suite that fully describes my system. Everything that's important about my system is embodied in the documentation that goes alongside it. Obviously, the answer to that is always going to be no. But the thing that we're thinking about is, how close to yes have we got? So, in summary, there's a lot of words. High code coverage means nothing. Low code coverage means something really dangerous. But high code coverage just means nothing. 100% is not something to aim for. Functionality coverage is what matters. Describing what the system should do, what your classes should do, and what your methods should do is what matters. Our tests should be as expressive as possible, they should be as concise as possible, and they should be as precise as possible, so that when we read them, we can understand them. Hopefully, they should be as complete as possible from that functionality perspective, but they don't have to be absolutely complete. And most importantly, they have to be readable. A test that has never failed has never passed. If you've never seen that test fail, you cannot make any stock in the fact that it now passes. And a test that cannot fail is not a test. And when we're writing our tests, what we should be testing is the functionality of the system, not the implementation that we've decided upon. And that's it. That's my preaching over. Any questions? Yeah.
So I've come across people putting unit tests in for declarative solutions. What's your take on that?
I have done that in the past. Absolutely. I think it depends on your environment, and it depends on the skills of the people that you have available. If you have a very developer-heavy environment, then I think it's absolutely valuable. You can do a huge amount with configuration. You can very easily break your system so that nobody can create a contact by adding a validation rule that makes no sense. In my opinion, so I don't want to be too antagonistic about this, but any change that you make to a system that will change the behavior of the system should fall into a test cycle. You should not be allowing anybody to make any changes in your production environment that could potentially break the system. So the starting point is that. how much you want to then invest in making sure that all of your declarative solutions are covered by test cases is a big question mark for the environment that you're in, and as I say, the people that you have available. As a developer, I would quite happily use a formula field when a formula field is appropriate. I would consider writing a test for that formula field if I knew that that's not going to stop people in the future from making subtle changes to that that are not material in the behavior change of the system. So the answer to that is yes, sometimes.
Are you also aware of Sarah Sally's stuff on mutation testing?
No. Yeah, I would like to. Yeah.
So it's not so much questions, observation. You did mention run as or testing against particular profiles and user types.
Yeah, there's lots of things that I haven't covered in this. Yeah, absolutely. Run as is a real bane. Apex sharing rules. Why you can't test them, who knows? I'm sure somebody will be able to explain it to me. Yeah, I think I'm going to focus on users there. Users are something that they're hard to test with. But you can create users of the right profiles if you do it at the right time. And with test setup, you can set your suite of users up prior to doing anything else and you don't get your mixed DML issues and so on and so forth. So there are some things that are harder to do in Salesforce than they should be. But that doesn't mean that they're all impossible. Some of them are impossible, but not all of them are. If you have lots of different types of users, and it's absolutely vital that the differences in behaviors between those user types continue to exist. Now, obviously, all functionality is there for a reason, but there are some things that you have to measure the cost of the test against the cost, the risk of it going wrong. And so, yeah, I would say what you're doing is you're looking at the profiles, you're looking at the user types or whatever, however it is you're expressing that, and you want to make sure that you don't do something in the system that's going to awfully break the system, I guess. If the cost of implementing a test is high, you want to make sure that you get something back out of it, which is one of the reasons why I say that 100% coverage is not an aim, really, because some things are really hard to test. And expending that energy testing something that's really hard doesn't really describe anything of great value, and the impact of that going wrong is very low, then it's probably not worthwhile doing. But if it is absolutely vital and core to the way in which the system runs, then yes, absolutely. I would create data under different users and so on.
Moving to permission sets makes it actually a lot easier to be atomic in what you're actually verifying. There's an umpteen profile, some of them you probably have to check it. Using permission sets for that critical piece of functionality, you can control things in much more different way.
Yeah.
So it's often can be tempting, or I'm sometimes tempted to test sort of a number of methods for testing different classes with a single test, and for a couple of reasons, one is it's quite easy, but often it's really quite an expressive way of saying do you have a perspective on how to test tests? Do you feel that you always have to test every single method, and should you combine that with those more?
Yeah. So the question is, should we combine? Can we combine tests so that we group classes together and we test the behavior of those classes in cohort, or should we always make sure we're testing our things independently? I think there's definitely value in both. I would tend to ensure I'm always covering individual classes to make sure those individual methods behave in the way they advertise themselves to. But that said, there is also value in saying if I have a certain framework, for example, if I'm using dependency injection and I compose something out of lots of different classes and I want to make sure that behavior makes sense as a collective, yeah, I would certainly write a test that covers all of those things. That's a different type of test. That is not really a unit test anymore, but it's a kind of an integration test, for want of a better word. But yes, absolutely, I would do that in any environment, including Salesforce, if we've deconstructed something enough. Yeah, definitely. Yeah.
I know you sort of said because of your background, the whole test-driven development thing, you've done that, but it's not really quite what you do in Salesforce. So I've sort of tried to do the same in the past. You know, I've got knowledge superior, I'm writing a test first, great, but as you said, you tend to go and write like signatures first, and then you come back and do your test. And what are some of the pitfalls you found at trying to do proper test-driven development?
The biggest pitfall is the response time, if I'm honest. If you're doing pure test-driven development, what you're doing is making very small changes on both sides of the coin in quick spurts. And the difference between running a test on your local machine that takes 26 milliseconds and running a test on a cloud server that takes 2.5 seconds is vast when you're flicking backwards and forwards all the time. I would say that's probably the only thing that really stops me from doing it. The environment that I've done most unit testing in is PHP, which is not compiled. So that's incredibly quick for you to get those results back. And also that allows you to test a class where you simply haven't defined anything in it except for the name of the class. I mean, I was thinking about it, even then you don't even need to do that because it will run it. It will give you a runtime error, but it will run it. With Salesforce, you can't do that in the same as any other compiled language that's strongly typed. You have to have built a scaffold before you start to do anything of any meat. So because you have to do that, it does tend to lean you towards filling in a little bit on those signatures before you write that first test. That said, as I say, I was always a big fan of test-driven development, but it was never that first piece of code that you write that really was the value in it. It was much more about that stopping and thinking, right, I've done a very small amount now. Now I want to add a test that's going to just push that functionality a little bit further, and now I'm going to change my code so that it fulfills that functionality. Now I'm going to add a little bit more test and add a little bit more functionality. It's that constantly going back to the test and looking at it again. Whereas what I tend to find in the Salesforce world, and I have to say, I say this kind of Salesforce world, obviously my Salesforce world is in Make Positive. I don't think this is necessarily a criticism of Make Positive, obviously. But people tend to separate out, I've implemented my code, now I'm going to implement my test, which is the extreme other side of test-driven development, isn't it? And when you start to think about that, so think about writing your test in that kind of way, it really stops you from generating half of the value of writing your test. Yes, I've talked a lot about writing tests as documentation because I think they live for as long as your system does, and you have to be able to read them. But a huge amount of value that I get out of writing tests is really testing the boundaries of the things that I've just written. And if I think about my test as an afterthought, then it starts with the assumption that the code I've written already works. And I think it's that bit of test-driven development that I'd like to see becoming more common, which is I'm going to prove something in the true sense. I'm going to check that it does things correctly in different scenarios when I write my tests. And I'm not going to assume that my code is correct when I do that. Does that answer your question?
I was curious. I've tried to sort of you almost really discover the test and you almost just end up with a whole bunch of code comments like, I think it's going to do this, because the times I've actually tried to implement the test first, it bigly could have ended up falling down a hole. It doesn't do it, I have to randomly change the way I've done something. And then I end up just having to come back and rewrite the test. I'm like, why did I try to do this, but it didn't work. So if anything now, I maybe just start to say, these are the comments, I put those in and say, that's the start point. And then I'll come back. I've got some of it.
Which really, I think, is the point I was trying to make with the planning your tests, where it takes a lot of work to write tests, particularly in Salesforce, because of the fact that we're so tightly coupled to the database. Sketching out how the behavior should be exhibited, I think, is the key value out of test-driven development, for me anyway. Yeah. Anything else?